Hello, all. Welcome back to software maintenance class. In this lecture, we are going to see what is code smell, what is refactoring, and what exactly is this technical tip in the context of software maintenance. So, if you see this slide, the indicators of a system decay. In our first lecture, we have discussed basically there are three different issues, which results in system decay. Which the first one was the technical issue, and in technical issues, we saw there were three different parameters which affects uh, which comes due to first one is because of very large component, and the second one was over rely on complex structure, and third was running in emulation mode. And we also saw that like there was some management issues also were also there, which results in system decaying, and these management issues were more related to where because of high personal turnover, deficient documentation, and finally we saw there was some quality issues which happens because of frequent failures. If there is an excessive resource requirement, and of course if you use different technologies in one system. So these were eight different parameters on which we say the system has started decaying. And but the thing is, how what exactly is like how we can improve the system. So it turns out that we can improve once the system has been designed, and if proper development development logics and the documentation has been followed, it turns out that we can improve the system. But technically, the system can be improved during the maintenance only, not very often done, not which is not very often done, but still an aspect. So when we talk about we improving the system, there are three different things which will come into the picture. The first one is code smell. The second is code refactoring, and of course the third is technical debt. Let's see one by one what exactly these three factors are. Let's start first with technical debt. What exactly this technical debt is in software maintenance. So basically, these are three different definition of technical debt. If you see in literature, which has been given by three different authors, and what technical debt over here is actually is you have a code now. You want sorry you have a product, and you want to build a product, and you want to deliver the product fast, but during the delivery or during the development process, you have followed some shortcuts, and you have used whatever techniques you can use to do or to bypass a few lengthy approaches. Maybe you have not followed the testing part of each modules, or maybe you have done the testing of few modules, and the other you thought, okay, it's working correctly. So the basic idea of technical debt is the amount and the cost which is going to affect the shortcuts which you have taken during the development process, and of course in previous maintenance cycles, if the product has been revised after its first version. So the other definition, if you see on the screen, it says delay technical work is occurred when technical shortcuts are taken, like the shortcuts which I just mentioned. Maybe you have not done the testing part, or you have not done the development part. The coding part has not been done correctly. You have not used the classes and methods, and you have not declared the variables inside the classes. Rather, inside the classes, rather you are using it. There is a difference between global and local variables. So you have not used or the proper way to bifurcate this global and local variables. So the proper coding practices has not been followed. So we say, just like financial debt, some technical debts can serve valuable business purpose. So so the basic symptoms of technical debt, if you see, is sometimes the developer, if you see, they exactly they don't know what is the better solution, and they start writing the code, and by the end they get a product which is being delivered to the customer. But it turns out that after using the product, when it comes back to you because of some failure, or maybe because the customer now wants to add some features in it, it is very hard to it is very hard to work on it, or it is very hard to revise, or or to rework on its newer version. And of course, sometimes also it happens the developer might think the deadline is approaching very near, and it's very difficult for them to deliver the deliver the product, or maybe the module on which they are working in that particular deadline. So because of tight deadlines, also it happens, and the bugs comes into the picture. And later, when the when the software or the product is being used, it turns out that, okay, now we have the product, but it's not functioning, or it's not working properly to its expected capability. And it is also it happens like these symptoms of technical debt is also related to development shortcuts, which we have discussed, and late deliveries, long delivery time. In the market, if you want to be in the market, you need to release your product as fast as possible, but it's not possible to deliver. But with the existing team, it's not possible to deliver the product fast. Then you take shortcuts, and it turns out that during maintenance you are spending a lot of time fixing those shortcuts which you have taken during the actual development process. And of course, there is also like if there you there is lack of knowledge about domain, but the project has been evolved and the codes has been written, and now the new code which has been written does not meet the requirements. So the natural evolution of the project also leads to technical debt. And of course, if you are having some frustrated and poor developer teams with you, then it is very difficult to it is very difficult to work with those people, because you will see that clashes between the rushing for deadline is going to happen with the poor developers. So if you see this graph, which I have taken from codescene.com, which if you see this diagram, there are two in this graph. The x-axis talks about the months, and the y-axis talks about the money which we have, which the software development companies are spending on their work. The planned is in pink color, and the unplanned is in lighter pink. So if you see on the right hand side, it says for planned work, the 54.67 means more or less 50% of the teams spend their time on the planned work which they have to do. However, the other 45%, or between 40 to 50%, the time is wasted on unplanned work. So the average organization, by this graph, we see the average organization waste around 40 to 50% of the development time because of this technical debt. And if the organization spends more than 15% on unplanned work, then that's a warning sign that that the delivery potential is wasted. And of course, technical debt is likely to be a significant chunk of that waste. So what are the different technical debt metrics? So it turns out that if the code has been written in such a way, like there are a lot of duplicacy is there in the code. For example, writing a function, there is a function which performs some which performs a task. For example, for which helps you in logging into the system. However, you have designed another function which helps you logging for the another for maybe for different people. For administrator, you have designed another login function. However, writing two different functions for login will we can say that it's an duplicacy in our code, and we can always remove the second function, and with the help of with the help of the first function only, we can override the first function and we can use the second function. Maybe we can put few more functionality in it, just to make sure that the admin can log in with the same function. So you you don't use a lot of duplicacy in the code. That means the technical debt can be less. However, it turns out that whenever there is a technical debt in a software organization, it happens because of the amount of duplicate code which is being used in during the designing process. Of course, the rules and the compliance has not been followed by the developer team during the development process, and it also happens the system has been developed in such a way that it is more using the third party softwares, and the dependency on third party software is so cohesive that during the maintenance you still need those packages, and support for those packages is no longer available. And of course, the method and the class complexity is another parameter which comes on the technical debt. You need to define the class and the method as simple as it can be done. And of course, if proper automated test coverage or the manual test coverage is not being followed during the development after the development process, then also it turns out that it will lead to the technical debt. So these are the list of metrics which also represent the priority to capture or fix or remove the bugs in the particular software. Because if you are following these practices, the technical depth in a particular organization can be elevated. So not only the process, which not only the designer or the developer are more, or the tester are the more responsible for technical debt. It turns out that the process or the management team is also responsible for technical debt. So we have seen like the poor coding and testing practices can lead to technical debt, where the shortcuts which has been taken during the development of coding, and of course, if you have not traversed to the entire software which you have developed, or the entire methods or classes which you have developed, if you have not traversed during the testing, it may happen during the maintenance. You are going to spend more time on fixing those things, because they have not been written properly, and the maintenance people may be different from the people who have actually developed the code. And yes, the poor system design is also another factor, because most architects over focus on a user feature and under focus on actual important qualities of software, and which actually is the maintainability, performance, reuse, and adaptability, which is directly related to technical debt. So you don't have a system you have developed a system which can't be maintainable, its performance is low, and it can't be reused. So whenever it comes back to you with certain changes, it is very difficult to work on it, and most of the time you're going to spend on rectifying or fixing those things, rather adding new features to the existing software. Poor communication and collaboration is another parameter which causes technical debt. Let's say if you are having a number of people in your team of 10 people, and you don't discuss exactly what you have done in a week or maybe in a month, or you don't schedule the people work exactly the timetable to them. So in that case, the technical debt can increase high, because you are not aware of what actually the other team members are doing in the team. And of course, if there is no standard followed during the development process, it can also lead to technical debt, and a lot of manual effort has been used for releasing the particular product. Automated testing or automated logical things have not been used, the software has not been used during the development process, can also lead to technical debt, and of course, lack of proactive investment in paying down debt. So, what is the repayment plan? How can actually we can fix uh, this technical debt? So it happens the engagement and motivation, and there should be a plan which should lead to an exponential value to the customers. And we can do this thing by four different factors, which is, for the first one over here is we can engage the executive management team in explaining exactly what this technical debt is and how much time we are going to spend on this unknown task, which we have skipped during the development process. We need to explain how it can impact the response cost, delivery, and morale of the team members, and of course getting by in to make the necessary investment to pay down the technical debt. uh, when we say pay down the technical debt, it means we are spending the time of the developer on this unplanned works, and of course and proactively managing it going forward, and you need to manage those unplanned works properly in order to repay the debt of technical of this which has happened because of this technical debt. And there needs to be a realistic plan which you need to implement on the ground for repaying the debt, and which should have a proper governance model. There should be some people who are going to see exactly what the developers or the different entities in the team are doing. And when interacting with high rank executive, it would be very helpful if we can explain the technical debt as an analogous as financial debt. And of course, you need to run some preventive maintenance cycle and to increase software maintainability. So the next thing is code smell and refactoring. So what exactly is code smell and refactoring? So first, let's see why do good developers write bad software? So they are in a team. There may be very good developers who deliver the product or who do their work before the deadline. But as the requirement changes over time, it is very hard to make changes or to update your own existing code which you have written, and which this phenomena can lead to a less optimal design. And once the design has been compromised, it turns out that the software which will be delivered to the customer is going to come back very soon, and because of some maintenance or because of some bugs which may not work properly, because of those bugs the software may not work properly, and it is going to come back to you for the maintenance. The good developers wants to save it's their time and money, and they take some shortcuts. They have not thoroughly checked or the code which they have written. Maybe there is a lot of duplicate codes. They have used so much long parameters in the methods which they have used inside the classes. And because of these shortcuts, the good developers often develop a bad software. And yes, you learn a better way to do something. The second time you paint a room, it's always better than the first because you learned during the first time. So it may happen in the team. Yes, you have good developer, but it's their first time they are working on this particular module, and they also don't have the enough expertise about how exactly it will go. And whatever knowledge they have used their existing knowledge to develop the software. However, once it comes back to them during the maintenance, it can be developed. But the thing is, they are good, but the expertise of developing a software is limited, and in this case a bad software often gets released. So how exactly we are going to fix the software, or how we can say the software is bad when it works fine? So in this parameter there is the code smell comes into the picture, and exactly a code smell is a problem in a source code that is not a bug or strictly or technically not a bug. uh, we cannot say exactly it is a bug, but code will still compile and work as you expect, but it indicates a violation of design principles that might lead to problems further down the road. For example, like we have discussed, a duplicate code that was copy and pasted in several places in the source code instead of creating a new method and referencing it from each of those places can violate the coding practices. And this is exactly is what we are referring it as a code smell, where we have taken a shortcut and we have not invested a lot of time in quality coding. So this code smell can often occur both in production and code and test code, and there are different factors mentioned by the author Martin Fowler, which is which exactly happens uh, because these are the different parameters because of which we say the code has been compromised. For example, uh, you have used alternative classes with different interfaces. You have not used proper comments to whatever methods you have declared, and there has been long methods and classes. There is a long parameters list. You have followed duplicate methods in the same or a different class. The parameters are long, and of course, there are some data clumps. Data clumps basically is a group of parameters that are frequently used together. For example, name, username, name, and password. And of course, packaging them together in a class cleans up many redundant references. You have not used proper switch statements. There is lazy class, and a lazy class basically is one that doesn't really do much things, or it performs few trivial operation. And by the end, these lazy classes should be removed from the existing code. Because if you are having a lazy code in your lazy class in your software, it will be it is going to make this maintenance process very difficult. And of course, there are other parameters like message chain. A message chains means there is one class which is referring the another class, and it may happen that the another class is also referring another class. And then by the end, it is very inefficient to work on such classes because the readability is very low for such codes. There is another parameters which is middleman, uh, which middleman basically is a class that exists solely to reference other classes. And if the class does not have any independent functionality, maybe it should be removed, because again, uh, having so many middleman classes in the code can lead to difficulties in maintaining the particular software. So similarly, we have Van, who has also mentioned different code smell thing: mystery guest, test run, where general fixture, eager test, lazy test, test code duplication, sensitive equality for testers. So you can go through these different parameters and you can just check what exactly these are in these terminologies are in terms of code smells. But the thing is, what exactly is a refactoring? So basically, refactoring modifies the software to improve its readability, maintainability, and extensibility without changing what it actually does. So we are not here to add any new features. You have an existing software or existing product. Now you want to work on that particular product in such a way that you want it to improve in terms of readability, that it can be understood very easily, maybe in the next round. And if the readability has been increased, then it will be very efficient in maintaining and so on. So refactoring is a method where you target the code smell part and you try to modify actually what has been written. So, like I said, the goal of refactoring is not to add a new functionality. However, the goal of refactoring is to make code easier to maintain in the future. So you don't have to add any new features in the code, whatever, when it comes to the maintenance part. You are just working on the existing code and you're just trying to make that particular code easier, or maybe you follow certain guidelines just to make those codes easier to be maintained in the next in the round. So refactoring can introduce problems because anytime whenever you are going to modify a particular software, it is going to introduce new bugs, and this can lead to a delay of the project. But and of course, testing a module or doing refactoring on a particular module can be a high risk because from management point of view also, because you are changing an existing code which is working, and but you want to make it you want to make that particular code simple, as simple as much possible, so that it can be used properly in the future. However, working on the same code is very expensive because the development team is spending their work on the existing codes, doing the task of refactoring, and there is a huge money which is getting invested in performing this refactoring task. So the question comes, why are we doing this? So we are doing this because refactoring may be the single most important technical factor in achieving agility. So these are the different talks given by different authors why exactly we are doing the refactoring. One thing can be we want to there is a lot of duplication and complexity, and we need to remove this duplication and complexity from our code during each code session, and even during removing this duplication requires modification, but we are willing to do this modification. And of course, at certain point of time, automated unit test can also be used to verify every changes in this. The other definition from Beck is a change to the system that leaves its behavior unchanged, because you're not adding any new features. You are just working on the existing system, but enhances some unfunctional quality. And those unfunctional quality can be in terms of simplicity, which we are saying from continuous 2 or 3 slides. It can be flexibility, it can be understandability, and of course the performance. It can enhance the performance. Similarly, we have another definition from Martin Fowler's, which says a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. However, the composite definition of refactoring is we are interested in making some changes to the system. However, those changes are not observable behavior, and observable behavior means all the tests has do not change observable behavior. Means if there is a certain features in your system, we should not change that particular we should not change that particular feature. Means the software should provide that features, and of course the testing should pass once the changes has been done. You need to remove duplicacy from the code, and in order to solve the complexity of the entire coding practice. You need to enhance software quality. Software quality means you should not use multiple technical techniques, technical or technologies in a single system, or you should not heavily depend on external resources, and the system should not be failing very frequently. So you need to work on these three different factors in order to enhance the software quality, and making the code simpler and easier to understand can also be said to be a best practice for working on refactoring technique and making the code easier to change. So these are the different things which exactly we are working on a refactoring technique. So why actually we refactor? Why there is a need of refactoring? Because like we said, we are not adding any new functionality. There is a software which is being used, and now we are just working on the existing software. So we want to prevent the system, the entire design from decaying. So because if we have if there are a lot of code smells in our system, it will turn out that when the software is in its second version, or when we are performing some maintenance on it, it will be very hard, and we are going to spend a lot of time on working on working on these factors, which we have skipped during the development of the actual product. It is going to clean up the messes in the code, like we said. The duplicacy in the code can be cleaned up. Long methods, long parameters will not be used when the refactoring has been done, and which is going to ultimately make the code simple. It will increase readability and understandability of the entire code. We need to find bugs, and we need to reduce those bugs. Uh, of course, we need to reduce the bugging time, because as long we are working on the same software or the same particular module, we are investing a lot of companies' money on un beneficial money on that particular module. And of course, we want to build in learning what exactly we do about the application, and redoing this is a fundamental to every creative process. How to refactor? So we say, make sure your once the refactoring is being performed, make sure that your test passes. Maybe you can follow some regression testing, and you can just check the testing passes for all the modules which have been changed. Or and second thing is, you can find some code that smells. So we have seen there are a lot of factors or parameters are through which we can say a particular code smells, or smells means it doesn't work properly, and it can lead to some other non-functional disability or in the product. Now we need to determine how to simplify this code. We are going to use some simplification or simple process to perform the refactor. Then again, we are going to test, and we are going to ensure things still work once the changes has been done. And we are going to repeat the simplified test cycle until the smell is gone from the particular software. Means it is now readable, it is now maintainable, and it is less prone to bugs. So this is the refactoring flow cycle. We are going to ensure all tests pass. Then we are going to find code that exactly smells, which has different different issues in terms of, uh, like for example, if it has duplicate code logic, long methods, long parameters, and so on. So you need to find those things in the code. Then you need to determine simplification. Then you, of course, you have to make you need to do some changes, and you are making some modification to make the code simple. And once the code has been changed, you need to ensure that all tests should pass with those changes. So requirements for refactoring is, you need to collect. You first of all, you should have the collective code ownership. Then you need to follow some coding standards. The pairing programming needs to be followed when performing refactoring. Simple design, test, continuous integration, and retested programmers. All are these are different requirements that needs to be followed once the refactoring part is being performed. Now, the question comes, where exactly we want to refactor. So we can refactor anywhere where actually we think it is needed. So the thing is, tests exist and currently pass for the code to be refactored. Someone else is not concurrently working in the same code. The customer agrees that the area is worth the time and the money to refactor. So these are the three different places where exactly we can also refactor. So we can refactor all the time. And the rule is, when you add functionality, when you learn something about the code, and when you fix a bug. So these are the three different places where exactly we can refactor. And of course, when the code smells means it looks problematic, then we can work on this refactoring thing to uh, make the entire code more readable and understandable. So when we should not actually refactor, when the tests are not passing. So you have done some few modification, and now the tests are not passing on those modification, then you should go back, or you should revert back to the same existing code. When you should when you should just rewrite the code. If the task is to entirely rewrite the code, then you should not perform this refactoring. And of course, when you have some impending deadlines for the delivery, then of course you should not do the refactoring. However, performing refactoring will take you, which will make lots of problem, and those problems will be like refactoring can lead to incessant tinkering with the code, trying to make it perfect. So you are trying to make the code perfect, but now the thing is it's not working properly as it was working earlier. And the second thing is when the tests don't work, or test when or the tests when the application doesn't work, leads to potentially dangerous situation. So changes have been done on a particular code, on the existing code, but now it's not passing the test. So in that scenario, we should not perform the refactoring, because this is a very big problem. Database cannot be refactored, because it is very difficult to refactor the entire database, and refactoring published interfaces can also lead to problem for the code that uses those interface. So if there is some existing interface or third party library dependency, you should not perform much refactoring on those interfaces. So why actually developers are reluctant to refactor? Because they lack of understanding. If there is less knowledge about domain, then it can happen. The developers may not perform the refactoring properly, and if there is short-term focus, they are not thinking for a long term, and the focus is just to deliver the product and give it by the deadline, and then it can happen the refactoring is not being done properly. Not paid for overhead tasks like refactoring, because sometimes it happens that refactoring is an overhead task because you have been asked to add a new feature or fix a bug, but in order to fix that particular bug, you need to work on the previous functions or classes, which is not readable or which is not maintainable, and you need to spend a lot of time on it, but you are not being paid for the overhead which you are working for refactoring. And of course, there is a fear of breaking the current program. The developers may fear once they perform this refactoring, it may happen. The working of the particular software can go bad, and it may not function as it was intended earlier. So these were the three things which we have discussed in this lecture: technical debt, code smell, and refactoring parameters for software maintenance. So in the next class, we will see the next topic. And till then, bye.